I welcome you all to this video session. So in this video session, I would like to focus the first unit about the introduction about problem solving and Python programming, and as well as what is algorithm. So actually, as far as the first unit is concerned, already discussed in our previous video. So in this video, I am focusing what is algorithm and importance of algorithm, like this we will discuss. Before going to focus what is algorithms, this is the mind map of the first unit. The learners can understand what are the topics, technologies we are focusing here, we can understand. So the first unit, as you know, it is algorithmic problem solving. So in this topic, the first topic is algorithm, where we are going to study various characteristics of algorithms, and then building blocks of algorithms, where we are going to focus as statement, what is state, what is control flow, and what is functions, and like this. After that, so different notations to design a flow chart, to develop pseudocode, and different programming languages also. The machine level language, middle level language, and high level language, like this we are going to discuss. So then, so algorithmic problem solving techniques. So where we are going to take all the points of building blocks. Whenever the university examination asks the building blocks of algorithms, you can explain all the 4 topics, and then the algorithm analysis also we can give. And plus, that's different strategies for developing algorithms and analyze algorithms also we can give. So here we are going to focus the sequence structure, selection structure, iteration, and regression. So these the 4 topics are very important to analyze the efficiency of any algorithms. And finally, we are going to discuss about a few problems, and the problems, from the problems we can understand how to solve a small problems, or how to solve a complicated problems into different small pieces, and we can find the better solution, like this. So in these illustrative problems, so we will focus find minimum in a list, then insert a card in a list of sorted cards, and guess number, that is an integer number in a range, then towers of ni. Like this, the 4 different problems we will discuss, and we will discuss the technologies to find the solution also. This is the mind map. So the followed by mind map is the structure. So in this structure, so in this video, we will discuss about introduction as well as algorithms. Okay. The first we will focus what is the purpose of solving methodologies, or what do you mean by problem solving methodologies. As far as problem solving methodology is concerned, it is a sequential process of analyzing information. So after analyzing the information in the sequential manner, and we can find the best option or the best solution. Okay. So it has different steps. The number 1 is we wanted to understand the problem very clearly, because before developing a methodology to solve the problem, we wanted to understand the problem so that we can design the best model to find a solution. So the first step is understand the problem. Then after understanding, and the next one is we wanted to analyze the problem. So analyzing the problem is very important. Sometimes the problem may be very complicated, very complex, very large one. So at that time, so we wanted to divide the complex problem into sub-problems. That means we wanted to divide the complex problems into small, what is called problems, small problems. And after that, each small problem can be solved, and finally we can get the best solution. So that is the idea behind this analyzing the problem. So analyzing the problem, the complex problem we wanted to split, divide into smaller problems, and the smaller problems we are finding a solutions, and from the solutions we are taking the best solution. So that is the idea. Okay, once we analyzed, we will get ideas. Then after that, we can design a methodology to solve the problem or to implement the code. Okay, so the design methodologies, first we wanted to design the algorithm. Okay, that is a step-by-step algorithm. Okay, so that without any confusion, without any ambiguity, we can develop a model. Okay, so after developing that is algorithm, so that is for that algorithm, we can develop a flow chart. So from the flow chart, we can understand the exact sequence of the problem or the exact steps, okay, by which we can find a solution like this, we can understand. For best understanding purpose, okay, we can develop a flow chart. We will discuss in detailed manner later on. And after developing a flow chart, so we can design the pseudocode. So the pseudocode is like English statement, but from the pseudocode we can develop a code. Okay, so for this purpose we wanted to use the pseudocode. So the designing process, first we are designing algorithm. After that, for the algorithm we are developing a flow chart. After that, based on the flow chart, we wanted to develop a pseudocode. It's okay. So now analysis over. Then after that, designing the algorithm is over. Then after that, if required, we can refine the algorithm, because always we wanted the best solution, the better accuracy, so that okay, the algorithm wanted to design in the best manner. For this purpose, after designing algorithm, if you realized that if you wanted to modify or if you wanted to improve that algorithm, the algorithm can be refined and okay, review. Okay, so under this review level, if you, that is expertise, ensured that this is the best designed model which will give the fantastic result with the highest accuracy, then we can finalize that model. After that, based on the model, we can develop a code. So that is called programming. Okay, so after programming, we are executing program and we will get the output. Okay, that got output, that result we can test and validate. And if we are convinced with the output, for example, the one prediction, the prediction is I wanted 95% of accuracy. Okay, so from the result, I realized that I got 96% of accuracy, then we satisfied. And we ensure that okay, the proposed model, proposed algorithm is working very well also. So that so they just test and validate what is called a level, ensure that the proposed designed algorithm giving a fruitful result. Okay. After that, so we can create a documentation. The purpose is that how did you analyze algorithm? What are the methodologies you used to design the algorithms? Then if you are refined means what is the purpose of refining the algorithm, what parameters noticed, what parameters addressed, what type of contributions in this refining algorithm, like this we can note it down. Then after that, code development. Okay, so this is the one sequence. So from the sequence we can analyze the problem, okay, and we can get a solution. For the solutions we are developing algorithm and implementing algorithm, and we got the result. So this is the general idea about okay, the methodology to solve the problem. Similarly here, okay, it is a pictorial representation. What I demonstrated, so it's here. So when you are writing in this university examination, so this explanation plus the diagram is very important one. So in this diagram, so okay, identify the problem, okay, first level. Then after that, analyzing the problem, and during the analysis, okay, we will get some idea. Then after that, if you wanted to improve that performance further, you can refine the algorithms. After reviewing algorithm, you can refine further, so that we will get to the final stage. Then okay, so you can implement, and obviously you will get the best solution. Okay, so this okay, that is 1 2 3 4 5 6 7 7 steps. So these 7 steps will give you okay, a great, the best solution for any complicated problem. The first one, understand. Second, analyze. Third, design. Fourth, refine algorithm and review algorithm. Then develop the code. Then execute the code. Then test and validation, and finally documentation. So this is the small introduction about the problem solving methodologies. Okay, so learners understand the concept, and if needed, okay, repeat the video. That means watch the video again and again and understand the concept. Okay, so next one is algorithm. Okay, so that is first I would like to highlight, define what is the algorithm. So tens of what is called the definition that are available. I would like to take two definitions. So which definition it is comfortable to you, you can take it. The first definition is the algorithm is a finite set of instructions. True, it is a finite. Finite set means okay, unique sets, okay, clear input. Finite set of instructions used for solving problems. Okay, and not only that, how to solve the problems. Okay, we wanted to execute the instructions step by step. That is the first algorithm, first definition. And the second one is the algorithm is the sequence of steps to be performed in order to solve the problem by the computer. So algorithm is nothing but it consists of number of steps. Okay, the purpose of steps is to solve the problem. So let us consider this small example. You can understand. This is the one what is called algorithm. The purpose is to find the sum of two numbers. Okay. Then what are the sequence of steps? The first step start. Second step read the numbers n2, n1 and n2. Then you calculate a sum. Then okay, display, that is the result which you calculated. Then stop. As far as this algorithm is concerned, okay, 5 sequence of steps, 5 finite set of instructions. Clear? Then after that, to solve the problem, we wanted to execute step-by-step procedure. For example, after start, we should not calculate a sum. That means after start, okay, we wanted to read two numbers. Then after that, we wanted to calculate sum. Then after that, we wanted to print. That's the reason why that's the definition is coming like this. Step-by-step procedure for solving the problems. Okay. And not only that, these problems, these statements, okay, should be ordered and unambiguous and finite. Okay, ordered means it's a sequence, and unambiguous means no confusion, clear cut input. That means after this instruction, which instruction to be executed next. Like this, a proper sequence wanted to give. Okay, that's the reason why it is called ordered, unambiguous, and finite in numbers. Like this. See the example so that you can understand. Okay, so all the statements is executing one by one and you will get the result. Okay, so this is the idea about algorithm. So algorithm is a finite set of instructions and a sequence of steps. Okay, one by one wanted to execute to solve the problem. So sequence of executions to be ordered and finite. Okay, and one more information is, for example, a particular problem, okay, need a particular time. That means execution time and what is called space. That means memory usage and execution time is unique for a particular algorithms. Okay, that means for a different algorithm, there is a different execution time and a different memory usage. Okay, so our idea is, okay, if you wanted to design the best algorithm, I wanted highest accuracy, that is number one demand. Number two is its execution time should be minimum. And the third one is this program or this algorithm wanted to consume less memory. Okay, the three parameters very important that we will discuss later. So this is a small introduction about algorithms. And next one is various characteristics of algorithms. Okay, so very important concept. Now you know very well what is algorithm. Now we are talking about the characteristics. The characteristic means the first point is each algorithm needed to supply one or more than one input. True. See this example. Okay, as far as this algorithm is concerned, it is used to convert the temperature. That means from Fahrenheit to Celsius. Okay, I am calculating Celsius. I will give input as Fahrenheit. So Fahrenheit I will give as a input. Then from this what is called equation, I will calculate a Celsius. So this is a small algorithm for converting temperature, that is Fahrenheit to Celsius. Okay, first point is each algorithm needed to supply one or more than one input. True, because okay, that is input is required. As far as this algorithm is concerned, one input Fahrenheit. Next point is each algorithm needed to produce at least one output. It is required. So after execution, obviously we will expect a result. That's the reason why algorithm needed to produce one output. Okay. So as far as this algorithm is concerned, okay, the output is Celsius value. See, it will print. Okay. The third point is instructions in each algorithm should be very clear, true, very precise and unambiguous. You know very well, okay, no confusion, it is very clear input and precise, clear cut message, exact information. What I wanted to do that the algorithm should explain. See, for example, see, read the step 3, C equal to 5 by 9 into F minus 32. So it is a precise, very clear and unambiguous. Unambiguous means no confusion, no mistake. Okay, so that is the characteristics. And next one is instructions should not be repeated indefinitely. True. So for example, finite numbers, maybe that is 100 lines, maybe 1000 lines, maybe 1 lakh lines, it's not a issue, but okay, number of lines should be finite. Okay, because if no limit means okay, we want to get the result, the program will be executed continuously, it will create a problem. So that's the reason why instruction should not be repeated indefinitely. That means instruction to be repeated finitely. Okay. And the next character is each algorithm should be written in sequence. Yeah. The step 1, step 2, step 3, like this. Okay. Sequence is very important so that we can understand that algorithm. Based on that, we can develop a code. Okay. Next characteristic, each algorithm needed to terminate a step after a few finite numbers. True. So each algorithm, okay, there should be a termination. Okay, that's a very important one because after printing a result, okay, that algorithm should be stopped so that the program will be stopped. Next one is each algorithm should be feasible for execution. Yes, the algorithm should not be complicated. It should be feasible for execution and it should be very simple and it should be very effective. And next characteristic is desired result should be obtained at the end of the algorithm. Obviously, once we are developing algorithm, so that result is required. So that is one of the characteristics. Like this, okay, that is various characteristics can be developed and can be explained for the algorithms. These are the possible characteristics of algorithms. My dear learners, okay, understand the logic and with this suitable example, with this algorithm example, you can explain all the characteristics.
Till now, we have discussed the characteristic of algorithms. Now we will focus the qualities of algorithm. So during a discussion of characteristics, already I told you the time complexity and the memory complexity is very important for any algorithms. When designing algorithms, we wanted to focus the three parameters. The one is accuracy, and the second time complexity, and the third one is the memory complexity. It's a very important one. Based on this qualities only, we can choose the particular algorithm is the best one. So that's the reason why when designing algorithm, we wanted to focus the three parameters. The first one is the time complexity. So time complexity means that if you are implementing the algorithm and during the execution, it has to take less execution time. That's a very important one. Reason because it should not consume more CPU cycle. If you are consuming more CPU cycle, so that the CPU cycle, the CPU efficiency will be wasted. That is the reason why. So during what is called that algorithm design or the designing issues of algorithms, the first parameter is the time complexity. So that when designing algorithm, okay, it has to consider that the time complexity should be minimum. See this example. So just for understanding purpose, I have taken this diagram. So as far as the diagram is concerned, so different what is called the data length, list length, and as the data length is increased, the time complexity of your algorithm is also increased. Initially it is 0 millisecond, okay, nothing wrong in that. So as the what is called data size is raised, okay, the time complexity. For example, consider if that is a data length is 1000, then approximately, okay, that execution time is around, okay, that is 35-36 milliseconds. See, you can understand. For example, if it is 1500, then around what is called 77 millisecond execution time. And like this, it is gradually it is increasing. In a way, it is okay. It is in this exponential pattern. Okay, nothing wrong in that. But if the algorithms, okay, maintain the time execution like this, okay, that means beyond a certain level, the execution time should not be increased. Like this, we wanted to focus when designing algorithm. So that is called time complexity. And the next one is the memory complexity. So when executing that algorithm should not consume more memory. See this diagram, you can understand. Okay, that is the program is executed. Okay, started. Then after that, as what is called the time is going high. Okay, that memory usage also it is going high. According to this diagram, three mechanisms or the three algorithms were compared. Okay, one is in this green color and the other one is in this orange color, purple color, and the third one is in blue color. As far as the diagram is concerned, you can easily understand that the algorithm which represent the blue color performing better. Reason because as the execution time is going higher, that means during continuous execution, it not consuming more memory usage. Okay, almost what is called same. Okay, and the second algorithm also it is okay. Okay, few fluctuation is there, but it is maintaining. Whereas in this third algorithm, as the time runs, okay, the memory usage also it is running. So for better algorithm, as far as this diagram is concerned, the blue color this algorithm is the best algorithm. Second, this purple color, and like this, okay, we can demonstrate. So that designing issues, second parameter is a very important. It is called memory complexity. And the third one is accuracy. That is a very important one. Reason because so when designing algorithm, its prediction accuracy or the classification accuracy always to be higher. Okay, that's the reason why when designing algorithm, the accuracy wanted to focus. See this diagram. This is a one simulation report. Different classifiers are there, and that is accuracy also compared. As far as what is called one algorithm, that is nearest neighbor, k nearest neighbor is concerned, okay, so actually its accuracy is around what is called 81 percentage. It's a higher percentage. Similarly, okay, the different algorithms also, SVM is concerned, okay, it is more than that is 82 or 83 percentage. That means that from the diagram we can understand that the particular algorithm is achieving highest accuracy, that is called classification accuracy, means that its error rate is very minimum. And like this, okay, when designing algorithms, the algorithms can be classified, okay, with in terms of time complexity, memory complexity, and accuracy. And additional two parameters also we can consider. Number one is if it is a good algorithm, it is a sequence order. That already we discussed. Obviously, it should be a sequence order. And the last point is very important. Algorithm should not be designed for a particular data set. For example, as a researcher, I designed one algorithm and I have taken the two data sets to validate this algorithm. Okay, I ensured that okay, the algorithm is performing very well for these two data sets, and my algorithm can be taken by okay, the second researcher or third researchers or anybody, and he can use his own data set or different data sets other than my considered two data sets, and that algorithm should be satisfied for those data sets also. That's the meaning that the algorithm should not be restricted to particular data set. That is called generality. Like this, the qualities of algorithms can be defined, can be measured in terms of time complexity, space complexity, accuracy, sequence and generality. Okay, so that's a very important one, maybe A part questions. And the next topic is advantages of algorithm. Already we spoke about algorithms and parallelly we discussed what are the advantages. But a specific point, as far as algorithm is concerned, see the algorithms. Okay, this is one algorithm already shown you. Okay, the algorithm is concerned, it should be simple to understand. Whenever reading algorithm, okay, I wanted to understand very clearly. Okay. Second one is stepwise description of the solutions wanted to understand. Third one is when seeing algorithms, I can easily wanted to debug. That means if any error is there, I can understand. And the third one is this algorithm is for programming independent of programming language. That means this I designed this algorithm. The algorithms can be implemented in C programming or C++ or Python or any other programming languages. So that is independent of programming languages. And the next one is, okay, this algorithm problem can be divided into smaller pieces or steps. Okay, so for example, this is, okay, that is 5 steps. Okay, it says problem is, here the problem is I wanted to add the number and needed to get a solution. Okay, straight away within a single line we cannot achieve. That's the reason why, okay, wanted to start, wanted to get the number for A1 value for N1 and N2. Then I wanted to calculate a sum. Then I wanted to print. Unlike this, okay, using algorithm, okay, the problems can be divided as a small pieces, okay, for better understanding, better implementation and to achieve the best solution. And the last one is each step of algorithm can be easily coded into equivalent high-level languages. After seeing this algorithm, okay, simply I can understand that. Okay, for example, this algorithm I would like to implement in Python. After seeing these steps, simply easily I wanted to implement. So like this, these are the advantages of algorithm we can list it down. Okay, so this is a part question. So obviously 6 points it is enough. So with this topic, so we conclude, okay, it is algorithms and its characteristics, advantages and the qualities of algorithms. Thank you very much for watching this video. Okay, I advise you learners, okay, watch this video frequently to understand the concept clearly. Thank you.